Okay, a few more problems. The directions are solve if possible. So, first of all, when you look at this problem, there's two fractions that you see here that have the same denominator. So it sort of makes sense to add the two fractions and write it as one. So x minus 2 plus 4, x minus 2 plus 4 all over x plus 2 plus 4 equals 0. So, if you look at the top, that becomes x plus 2 over x plus 2 plus 4 equals 0. Well, at this point, you maybe think, well, maybe I should move the 4 over and do some other stuff, but step back a minute and look at this. Hey, it's the same thing over the same thing. So no matter what the x is, the value of that fraction is 1. So really, I have 1 plus 4 equals 0. Guess what? Does 5 equal 0? No way. So, no solution for this one. All right, don't do too much solving if you don't have to. So, all right, there's 15. All right, here we go with number 16. The directions again, solve. Well, this one, I would factor it, right? Do you know how to factor that? Factors of x to the fourth, how about x squared? Oh yeah, forgot that, huh? All right, minus 6. I could use minus 1 and 6, 1 and minus 6, 2 and minus 3, minus 2 and 3. How about minus 2 and 3? Right? I need a positive 1 x squared in the middle. You can check that out the long way if you want. At this point, now that I have it factored, I can set each factor equal to 0 and solve. So x squared minus 2 equals 0. X squared equals 2. So x equals plus or minus the square root of 2. There's 2 answers. What about this one? X squared equals minus 3. And the directions said to solve, implying solving for real numbers, so this is not real. So you could stop right there. Although last year we solved these, and we would say x equals plus or minus I root 3, but that's not a real answer, so it's really not included. This is the answer they're looking for. Again, directions are solved. This one's a little bit tricky. When you have square roots, basically, to solve them, you want to end up squaring both sides of the equation so that you can get rid of the square root. But when there's 2 on the same side, that makes things complicated because when you square it, you have to do FOIL. So I'm going to move one of them to the other side. So let's rewrite this as minus square root 2x plus 1 equals 1 minus 2 root x. Now, when I square both sides, watch what happens. Squaring this side becomes positive, and it gets rid of the square root symbol, so I have 2x plus 1. When I square this other side, I have to write this twice and do FOIL. Hopefully you can do this quick in your head. 1 minus 4 root x plus 4x. Now, I still have a radical, so I have to go through the process of squaring both sides again. Before I do, I want to isolate the radical, so I'm going to put everything else onto the other side of the equation. Oh, you know what? Maybe I'm going to put the radical over here, because that will make it positive and makes it look less messy. So let's put 4 root x on this side equals 1 plus the 4x minus the 2x minus 1. Simplify that a little bit. So I got 4 root x equals 1 and minus 1 are gone, 4x, 2x. Now, square both sides again. You follow what I'm doing, right? You've done this before. All right, what does this become? 16x. What does this become? 4x squared. You with me so far? So, to continue solving this one, let me give myself a little more room there. Let's rewrite this as 0 equals 4x squared minus 16x. I moved the 16x over. Now, hopefully, you don't mind if I write it 4x squared minus 16x equals 0. I just like them this way when I'm solving. All right, I could factor 4x out of this, so let's rewrite it. We'll go up here. if I factor 4x out, then I get x minus 4. All right, so to finish solving this, let's do 0 equals 4x squared minus 16x. I like to put the 0 on the other side, so let's do that. Now I'm going to factor. How about 4x out of both? And that leaves me with x minus 4 equals 0. So now that I have it factored, set each part equal to 0. So 4x equals 0, so x equals 0, one answer. X minus 4 equals 0, x equals 4 is the other answer. And then you should check both of those to see that they work in the original equation. And if one of them doesn't, then you just put an x on it. But there you go for 17.